I think we're in business. So, I'm going to talk about JavaScript on TV. Maybe raise your hand if you've ever done any kind of development for TV, any kind of TV apps. We got actually a couple of people, so that's cool. Raise your hand if you love that. One guy. It's interesting. How's the refresh rate? Okay, so the GIFs look amazing. So I'm not actually just going to talk about TV and JavaScript, but it's more about making web applications on TV. So there's more involved than just JS. And so I'm Mike. I work for Opera. I do things in Austin. And I'm going to skip this slide because it's not very interesting. So we just have a few of these to get through. Some requirements. This one you have to sit through for 30 seconds. You can actually skip it. That's a joke. So I work for Opera, and Opera has been doing TV for a long time. So I'm going to give a little history of Opera on TV because I think it's interesting, not just because I'm trying to peddle products or whatever. Then we'll look at web apps on TV, some of the tools, and something called the Opera TV Store. But this was fairly interesting to me when I learned this. Did anyone ever own this, the Nintendo DS browser? Okay, so one guy. If you ever had a DSi, you had a browser built in by default. This was actually the first bit of work that we did in porting Presto to chips and architectures that are basically fancy graphic calculators, right? Like where you have no memory and it's super not powerful. So the very first version of the Nintendo browser, you've got these two things. You've got the bottom, which is the actual cartridge, and that was the browser, and the thing on top was the RAM expansion pack. And that gave you 8 megabytes of RAM so you could surf the web. And then later on, that got included in the DSi, which is fantastic and terrible at the same time. And then we put that on the Wii, which a lot more people have and use. It's really an interesting fact. I was looking at the usage stats of the DSi, and I believe today there are more daily users of the DSi than there ever were WebOS devices, which is fantastic and terrifying, right? So people actually use these things to access the internet. So this is what the internet looked like on the Wii, kind of challenging and weird. As an aside, there's actually a really cool library that this guy, Ryan McGrath, wrote called WeJS. I'm not really going to talk about it, but it's out there and it's on GitHub, and you can create games or any kind of apps using just the Wii, and it'll listen for and it'll poll the Wiimote and the sensor and all that fun stuff. So that's a possibility if you've got a Wii and you want to do something crazy. Right. So we first started doing Nintendo DSi stuff. And that, so we could prove that we could put a browser on a very technologically challenged platform. And from there, we've put browsers on TVs and set-top boxes and gaming consoles all over the place. There's a meatball vendor that's going to do a smart TV that'll be running Opera. Okay, so that's maybe the company pitch. I don't know. I found that to be interesting. So here's really what we're going to talk about is building web apps for TV. And I've broken up into a few categories, right? So you have UX. So when you think about building just a little web app, let's say you have a microsite, like some kind of car is launching a new car, and you're going to build that site, or you've got some internal logging tool at work or whatever. Like, we know how the interaction goes, right? You're sitting in front of the computer, you're looking at things, clicking, etc. It's pretty intuitive to us at this point. On TV, it's very different. So you're sitting maybe 10 feet away from the screen. You've got the remote. Entering in input is terrible. So I have a Sony Blu-ray player, and this is what it looks like when you open the browser, right? like, this is terrifying and ugly. And you have to find the options key, and it just gets worse from there. So this perhaps is the current state of UX on TV browsers, but I think we could make it a whole lot better. So when you think about what people do when they're in front of a TV, right? So like, you want to watch the news, see what Reagan's up to, and you're not really sitting in front, like reading your Facebook private messages with your mom right next to you. It's kind of a social interaction, right? So kind of this notion of like private message, DM or whatever, is weird and awkward on a TV. But where you're kind of sitting around and consuming group information, that makes sense. So that's something to keep in mind if you're thinking what would make a good TV app, right? Nothing private, nothing secret. Another concept which is somewhat related to UX is this notion of overscan. So this is a really cool graphic. This is one of the original design grids and images from Nintendo when they were making The Legend of Zelda. And you can see, you probably can't see because it's terrible lighting, but there's 4 little crosses near the edges, and that was laying out the overscan. And overscan, it's a pretty well-known phenomenon. You can learn lots about it. But basically, TV manufacturers, depending on how they set up their TV, it can be zoomed in, you could say, at a different level. Sometimes, back in the day, there would be information on the left-hand side of the screen that they would pass along in the TV signal. And so you had this action-safe area, this title-safe area, etc., where, depending on how that was set up, you could crop it and you wouldn't lose any of the vital information. This still happens today. It doesn't make any sense if you have like an HD TV, because you can have the 1-to-1 ratio, but my TV by default had this terrible overscan set up. So you want to keep that in mind as you're designing your app. I think a recommendation by some of our UX TV people is if you give a 10% kind of border, rather pattern, I guess is a better word, to accommodate for overscan, you're in pretty good shape. So here on my TV, it's a really terrible photo. It's hard to take nice photos of television if you have a crappy cell phone camera. So this is the W3C's website, right? Like, this is like typical at-home web browsing, reading specs and whatever. And this is what it looks like with overscan turned on. You can see the difference here. Like, you've lost the header, W3C. Like, you don't even know what site you're on. So that's just something to keep in mind. Okay, so on to navigation. This is the guy you're working with. Right now, kind of, I think the next big thing, maybe in the next year or so, we're going to have companion devices where you can interact with your TV on your iPad or your whatever. We're going to release soon some Opera builds that have UPnP support, device discovery, like DLNA stuff. So you could even do this over the web with a web app, etc. But for now, you're interacting with a remote control, and you've got, you can't see that, I can't see that, I apologize, but you know what remote controls look like. You've got up, down, left, right, and you've got an OK or an enter in the middle, maybe you've got a back. And then some of the newer ones have these yellow, blue, red, green buttons. And these are kind of like the bonus action buttons. And we can use these in our apps. But I'll talk about the buttons in a minute. But just simple navigation, how it works, is this concept called spatial navigation, or SpatNav. And so I've got a little demo here. So when you're pushing left and right on the remote control, so in Opera, if you hold shift and left, right, up, down, or whatever, you can do this on regular web pages as well. You get this little focus design, and this is spatial navigation. And so this is how it works with the TV. And so I'm just pushing right, and it's going clockwise, and I'm pushing left, and it's going counterclockwise. And that's not actually the default behavior. So you can control what you want to happen there. And you do that with a little bit of CSS3. So in the CSS3 UI spec, there's this concept of directional focus navigation. You have these properties, the nav index, nav right, nav left, etc., up and down. Corresponds to top and bottom. And so what you do, you have that property, and the value you give it is the ID of the DOM element. So you say, when I'm on card A, if I push the right key or the right button, I want you to hop to card B. And so you can kind of set up your navigation using these properties. And nav index, you can kind of think about that like tab index. If you've worked with some of the accessibility stuff, so you can control just by default where it'll hop, or what will be focused. So that's interesting. So also spatial navigation, is that code really tiny, or can you kind of see that? Okay, so spatial navigation is interesting because it'll react to mouse over and to click events, even though you don't have like a mouse or a pointer that you're clicking at, but it'll still react. So if you look at that, this is the code powering my amazing card game. It's like 3 lines of JavaScript, right? So I've got a reference to some cards. I have this little log that was telling me what had been selected. And then I'm saying, if I click on the card, add this rotate class, right? And as I mouse over it, it should show this log. So let's, oh, and then this is the PSA, really use that listener. Don't be terrible people. So let's look at that again and see how that works, right? So this is a mouse over, and to click, that's hitting the OK button, right? And then we can, oops. Right, amazing. You're probably curious when this game is going to hit the streets. I'm just working out like points and stuff. It's nearly there, right? So, but if you think about it, like that was a really stupid demo, but those are the basic interactions. Like that's the minimal amount of stuff you need to know to make a game or an application, right? You can hover over something and change state, or give visual feedback. You can click on something, and you've got, you can fire off some JavaScript, and you can move around. So, amazing, right? That looks really dark. But input. So, we kind of already saw something like this, but DOM3 events actually has taken TV input devices into account. And there's ways we can bind event listeners for event handlers, rather, for these various different keys. So on the physical hardware, you're guaranteed to have, on TVs, qualify that, you're guaranteed to have up, down, bottom, left, OK, and exit, right? That will always be there. Exit, depending on the hardware manufacturer, you really can't do anything with it, but you can know it's there. These back, return, blue, red, green, yellow buttons, they may be there, but you can't rely on them. So you can imagine you've made this amazing game where you have cows or something, and you're supposed to feed your cows, because if you don't, they die. So of course you think like, oh, the green button is how I feed my cow. But let's say your friend has a TV without the green button, they just die. So maybe you want to have the green button to feed the cow, but also somewhere on the screen they can navigate to a feed button, right? These are all great ideas. I hope someone's writing them down. We can talk about IP and other things later. So this is how you work with that, right? So currently in Opera, you kind of have these magic constants, dk-red, which map to these DOM3 things, key properties, or key names, yes, which is just like red, right? So that's how you would do that. We already know, I talked about the green button, but we already know this might fail because you're not guaranteed to have a red key. So it's nice to be safe and just do a little simple feature detection. If you have a red key, let's party. That's what the red key does. It's a cow party. So yeah, so that's input. It's not very complicated, but it's a little bit different, right? Typically when we're working on our web apps, we just assume that everyone's got their buttons. So CSS, there's not a whole lot to CSS. Typically, any of the fancy, shiny stuff that you want to use in your little TV web app will work. One thing to keep in mind is media queries. So that's the new hotness, right? Responsive media queries stuff. But if you read the spec, there actually is a TV media type, but you should never, ever use it because it will never work. Google TV doesn't recognize it. Most of Opera stuff doesn't recognize it. I think the Wii does, but the reason why is because there's so much legacy web content right now that says media screen and, right? I think in TextMate, if you do like style tab, getting caught up, it'll default to give you the style block with a media type in it. And what that means is if you had a TV that respected this media query, it doesn't identify a screen, and it means like half the CSS of the web would never work. So don't rely on this. But if you look at, so here's some of the aspect ratios, which I apologize you won't be able to read, but you can kind of get a general sense. In the top you've got 320 by 200, and all the way down at the bottom you have something called QSXGA, whatever that is. This is what you're dealing with. These are the various screen sizes, but you can break them up into 3 logical groups. And you can create a set, I guess, what do you guys call these breakpoints? The CSS guys call them that. It's kind of weird. But, so you've got a full HD media query that'll match, right? Your screen and you're at least 1920 pixels wide. You've got HD ready, which is between 1280 and 1920, and then you've got something smaller. So I think the top is, we call it 1024p, then 720p, and then HD ready. I think, right? So if you have these, you can go crazy, like, oh, I've got this amazing HD screen, so I'm going to have some sweet graphics, but if I'm something small, that might be wasted. Something also that's extremely useful is profiling your CSS, and this is possible on Opera TVs. You can use Dragonfly, and you can do remote debugging via the emulator, and you can actually profile the CSS selectors, and this can make a huge difference in your web app. It's kind of wild. I intended to include an example, but I just forgot. On GitHub.com, there's this one selector that takes like 3,000 milliseconds to match. And if you added like an extra class, it takes like 11 milliseconds, right? So you can make these really crazy dramatic differences by just kind of making smarter CSS selectors. Okay, so that's kind of the world of CSS. Obviously, like, you won't be able to use advanced layout stuff like CSS regions or whatever that aren't even in desktop browsers, really. But pretty much everything else works across Google TV or Opera-based TVs. So JavaScript libraries are pretty awesome, I think. We've got some library authors in the crowd. For example, Alex Sexton is a very famous library author. So does anyone recognize this chart? This is Belgian friend of ours, Matthias, made this. This is the size of jQuery. He's tracking the size of jQuery over time, right? So at the bottom you have 1.2, and at the bottom left, bottom right you have 1.8. And you can see, like, holy crap, this purple line is uncompressed. Like, oh my gosh, jQuery is a monster. And you might freak out. But then if you look at minified gzip, you see, like, okay, it's not really increased that much. But it's just a fun, scary, tabloid-like infographic. The point of that is this is what you definitely don't want to do when you're on a TV. Like, you remember so this is real, and I'm currently helping this one person create a web app for TV. They're from some very famous place. I won't say who they are, but they're essentially they're using Prototype, and they're using jQuery, and they're using 9 plugins, and they can't figure out why they keep hitting out-of-memory errors. And I suggested, well, maybe you should rewrite all your Prototype stuff to jQuery. And he said, no, it's Prototype-based, but I need jQuery because Prototype doesn't do JSON-P. Right? So you should be laughing internally, because that makes no sense. But you can't just load up, like, zillions of lines of JavaScript because it's easy because it'll kill your TV. And you remember, like, you needed extra memory in your DS, but we don't have these extra memory cartridges. So this is where kind of smart, small libraries make a whole lot of sense. Micro.js was something that Thomas Fuchs wrote. I think micro libraries were cool a few years ago. You can see Nope, for example, up here, which is a tiny little script loader. Also, there's this thing called Vanilla.js. It's a pretty hot framework. It's also just a joke, and I won't explain the joke, but yeah, I'm not sure what just happened there, but JavaScript, right? We don't need big libraries to write simple applications. You saw my little game was like query selector all and a for each over an array and a few other things, right? This is where your skills, your JavaScript skills are valuable. Sorry, what? Yes, exactly, right? You don't, okay, that's a good point. Like, you don't need jQuery to make up for the fact that IE6 is terrible because you're on a TV and you're on an up-to-date runtime that manufacturers are making sure, you know, every time I turn on my TV every few weeks, I get a new firmware and a new browser. Okay, so JavaScript, HTML5 and the DOM. Can you guys see what that is? That's like a diamond ring. It's rotating. You guys remember when Dion wrote this seminal article, HTML5 is a jewel that we need to cut into a weapon. I actually have no idea what that means, but it's a pretty sweet proof, right? So, in terms of JavaScript, the landscape is pretty amazing, right? You have ES 5.1, you can use everything that you ever wanted to. You can have native binary data running through your TV if you're crazy. The performance isn't great, but it works. And that's kind of the big takeaway is JavaScript works on the TV, you just need to profile it and find out where it's terrible, and work from there. On that note, it seems, my experience, right now I'm working on kind of like a real profiling and performance article to be written. But kind of the simple takeaway is all the basic stuff we ever learned maybe 2 or 3 years ago, like Nicholas Akis was writing, all that stuff applies to TVs now, right? We had less powerful browsers and computers. That's kind of where TVs are. Things are getting faster, but they're still slow. You can also just hit JS perf to see what your specific needs are. Storage is interesting, speaking of the DOM, though. So this is html5test.com, which is a hilarious site. But if you can see, I'm here on my TV, and it says I do have local storage, which is great. So I can write my app, and I can say if whatever, and I can query local storage, and I can get stuff. But then this is a page that will test how much stuff you can store in your browser. So Scott Gonzalez wrote this, and you can see on my specific TV, I've got 47K worth of stuff I can put in local storage. But you have to remember that local storage is stored as a DOM string, which are 16-byte representations of these strings, so you're actually, like, half of this is what you can put in. And so you think, okay, whatever, what's 47 divided by 2? I have no idea. It's probably like 23.5. That's a lot of stuff, right? So, big deal. But in fact, this customer I'm working with their web app that needs jQuery for JSONP, on his TV, it responds to local storage. You can do feature detection, but the actual size is 0, right? So feature detection won't fail, but the minute you try to put something in there, it explodes. Cookies are very similar. So local storage, cookies, they may be there, or they may pretend to be there, but as soon as you turn off the TV and turn it back on, it's gone. It's almost as if it was session storage. So I'm really curious what that looks like from the back of the screen, back of the room. You can't rely on that. So for kind of mission critical stuff, you may want to send stuff over the wire and save it on the server side. AV is kind of weird as well. The good news is H.264 rules the landscape. You know, all the TVs can natively decode these in hardware, so you don't have to worry about like WebM or OGG or whatever. you can just pump H.264 out to your users. But then certain implementations have bugs where you can only play one audio element or one video element at any time, so you can't have really rich games audio, right? You might have to use some of the more interesting hacks out there like sprites. And you can't guarantee that all the media events will fire at the right time. That's super frustrating. Okay, so that's kind of the major pain points in terms of the DOM and JavaScript tooling that's out there, right? So we have something, if you don't have a smart TV, if you just want to download an emulator, you can go grab this. And I've got it running, I'll pull it up in a second, but it's basically just like a VirtualBox image, which is the Opera TV emulator. And you can mess around with that, and you can run your local applications. I already mentioned Dragonfly, which is our developer toolset, which you can do this. You can't see that because it's dark, but you can pair your browser instance with your TV emulator, and then you can go wild. It's even got a little virtual remote control if you want to do that. So here I'm inspecting the DOM of a game that's running on my TV called Math Night, which I'll show you Math Night because it's amazing. Right, and you've got a console, etc. You can do all that stuff. Math Night I mentioned, so it's in the TV store, which I'll show you in a second. But the TV store is basically, so certain manufacturers have included this. So my Sony Blu-ray has this, like there's an icon when I fire it up, there's like Internet, which is the browser's terrible name. And then there's the TV store, and you can go to find apps. The architecture is really simple. So Opera hosts some metadata about your application on our servers, so the TV is pointing to that. And then when people install that, it's really more like bookmarking it, right? It's just, these are web apps, and that stuff is hosted on your side, which is kind of nice. You can make money if you're into money. It's not very interesting. You can like have ads in your apps, which is weird. But go wild. And that's where you can go if you want to learn about that stuff. Yada yada. Let's take a look at Math Night because it's so cool. Okay, so this is really dark and terrible for an environment like this, but this is the TV store. Let's see. It's a pretty sweet loading icon. Connected to the network. Yes. We'll give it a second. We're going to give it up. So that failed spectacularly. I've got screenshots because I knew that would happen, which is sad because I was going to do some live math with Math Night. Okay, so this is just kind of to give you an idea of actually, so I talked about how terrible developing for TV is, or the things you need to watch out for, but you can actually create these really fun, compelling experiences on the TV. So here's the splash screen Math Night, and it loads, and you can choose your difficulty. And so the objective of this game is you're a knight, and you're going to fight this rat. And you have to answer these math questions before your timer runs out. Right? So you can see on the bottom left, you can see how that shape corresponds to your remote control. And so 171 plus 50, okay. That math doesn't work out. It's really hard to take screenshots of this stuff. Right? So I got it right, and I hit this rat. And his life goes down. As I get this wrong, my life goes down. You know, you go and you defeat these rats, and you get a higher score, and you go on to fight bigger monsters. This is like my 6-year-old's favorite thing ever. It's like really, nerve-inducing. You've got this timer, and you've got a big ugly rat, and you have math. Some of my favorite things, right? So that's basically it. If you want to, here's this link. DevOpera/TV has a bunch of articles, which I've basically just regurgitated for you on stage. There's a lot more in-depth information, and you can get links to the emulator and stuff. And so that's it. Thank you very much.